Symmetric tree. Given a root of a binary tree, return true if it is a mirror of itself, which means it must be symmetric around its center. For example, in this case, if we flip the right side on top of the left side, it's a complete mirror of itself. So we return true. Consider this new example. If we flip the right side on top of the left side, notice it's not a complete mirror of itself. So in this case, we return false. We will solve this in O of n time. Consider the code below. We have a recursive function where we initially pass in the left subtree t1 and the right subtree t2. Now let's assume, for example, both the left subtree and right subtree were null. In this case, we would return true because it's already a mirror reflection of itself. Now let's assume one of the subtrees is null and the other is not null. In this case, we would return false because it's not a mirror reflection of itself. Now let's assume both trees are not null. We first check if both the trees have the same root value. We then recurse and call this function again on the first tree's left value and the second tree's right value. And we also recurse and call this function again on the first tree's right subtree with the second tree's left subtree. Consider this first recursion call where the values are the same. And notice the children in both the trees are null, so when we do a recursive call on its children, it will return true. And similar idea for the second recursion call, both their values are equal. And also in both trees, their children are null, so when we end up doing a recursive call on their children, we return true. And so overall, every single recursive call returns true, so ultimately, our initial call will return true. And here's the code to do so. Please like and follow for more.